Hello students.
Let us have a question of simple stresses. This question was asked in GATE 2016. A horizontal bar with a constant cross-section is subjected to loading as shown in figure. The Young's moduli of the sections AB and BC are 3E and E respectively. The figure is given to us. For the deflection at C to be 0, the ratio P by F is we have to find out, right? So here we are given with a bar which has two sections AB and BC. The modulus of elasticity of AB part is 3 times E and modulus of elasticity of BC part is E given to us, right? At B point, a leftward load is applied, that is P, and at C point, rightward load is applied, it is F, right? And it is given that the deflection of C point is 0, right? It means that delta L at C point is 0. If this is the condition, then we have to find out the ratio of P by F, that what is the ratio of P and F. This we have to find out. So let us solve this problem.
In this question we are given with a horizontal bar of total length 2L which is divided into two parts AB and BC. The modulus of elasticity of AB is given 3 times E and modulus of elasticity of BC is given E. The load applied at B point is P in leftward direction and load applied at C point is F in rightward direction. It is fixed at this point. We have to find out the P by F ratio if the deformation of C point is 0. The deformation of C point is 0 and it is fixed here. It means that there is no deformation actually. The total deformation in the bar is 0. That's why I written total deformation delta L. So delta L C, the deformation C point, means that total deformation of the bar is 0 because total deformation, there is no deformation of this point and here it is fixed. So here there cannot be any deformation. So these 2 points are fixed, no deformation. That's why total deformation in the bar is 0. So delta L is equal to 0, right? So if I divide it into two parts, suppose this is 1, this is 2. So I can write that delta L, that is equal to delta L1 plus delta L2 should be equal to 0. It means this thing. So deformation of this plus deformation of this should be equal to 0. Now, what is the load acting on total entire bar of the beam in AB part and BC part, right? So we can divide this into two parts using the principle of superposition. We can find out later on the deflection, the P by F ratio. So this is divided into two parts. One is AB, another is BC. Now here A point is not common to any section of the beam of the bar and C point is not common any section of the bar. So whatever load is actually at at C point, the same load will be here because C point is not shared by any section of the bar, right? So that's why here it is F. Then if here it is F, then there should also be F, right? And body is in static equilibrium. Body is in static equilibrium. It means that the rightward force should be equal to leftward force, so that total horizontal force in horizontal direction should be equal to 0. So that's why this F and this F should be equal but opposite to each other, right? So that the body BC may be in static equilibrium. Now at B point, the total force is P. F we have already applied. So what force should be applied so that the sum of these two forces should be equal to P? So we can apply here P minus F, so that this P minus F and this F may become total sum of these two forces may become equal to P. So you can see here these two forces sum should be equal to P in leftward direction. So F and F will cancel out and you will get the P in leftward direction. So P minus F can be applied here in leftward direction and it is compressive. Similarly here, if here it is P minus F, so here should also be P minus F so that body may be in static equilibrium. So in one part the load applied is P minus F, which is compressive, and in second part the load applied is F, which is tensile. The sum of these two forces should be equal to 0, so that total deflection at C point may be equal to 0. So delta L1 plus delta L2 should be equal to 0. So I can write delta L1, that is minus, because it is compressive, so minus P minus F multiplied by length, because our deflection formula is PL upon AE. PL upon AE, this is our deflection formula. So P, this is minus, P minus F load, because it is compressive, L length is capital L, upon area. Area is same, so we can keep it A, and modulus of elasticity, that is 3 times E, plus force is F tensile, length is L, area is same A, and E is single E, that is E, and that should be equal to 0. So this is the principle of superposition, that total deformation, the sum of all the deformation of the section of the bar. Now here E can be merged into 0, so we will get L cannot be equal to 0, so what we are getting is minus P by 3 and minus plus F by 3 plus F, L by AE taken out, which cannot be equal to 0, and this part should be equal to 0, right? This part should be equal to 0 because L by AE is taken out, and which cannot be equal to 0, L by AE. So we have got this remaining part, minus P by 3 plus F by 3 plus F should be equal to 0. We can further solve it, that 4 by 3 F by 3 plus 1, that is 4 by 3, F should be equal to P by 3. So 3 to 3 cancel. Finally we can get P by F equal to 4. So this is the answer of this question. P by F is equal to 4. This is the answer of this question.